So I'll begin. Good morning, everyone. Well, good afternoon. Apologies. Good afternoon. And welcome back to Indigenous Cultures and Knowledge. Today we're hearing from Associate Professor Duane Hamacher, an astronomer and cultural astronomer in our physics department in the Faculty of Science. Let me first of all acknowledge the traditional owners of the countries where we live and work. For most of us, that will be the country of the Wurundjeri people of the Kulin Nations. So I acknowledge their traditional ownership of the lands for many thousands of years and their elders past and present, and wish their young people the best in assuming the roles that are their legacy, being descended from these incredible elders. So one announcement to make, and that is people are asking about the object-based learning assignment. You'll see that there are two lecturers who've uploaded suggestions for object-based learning in their topics. I haven't yet reminded all of the lecturers to send a page of suggestions for the object-based learning assignments in each topic, but I will do that, and that includes myself. And we've had some queries about how to do this assignment. Is it 800 words, Shane, or 1,200 words?
1,200.
It's 1,200 words and an oral presentation. So because there are so many students and so little time, we're suggesting that, Shane and I are suggesting that you do a video of yourselves presenting your 1,200 word written assignment in, say, about 5 minutes, and upload it, and I'll distribute the responsibility to look at those videos to the appropriate lecturer, and also the 1,200 word assignments, written assignments for marking. So that's where we're up to with that. Over to you, Duane.
Thank you so much, Professor. Really appreciate the opportunity to come speak to everybody today. And I would also like to acknowledge that I am sitting on Wurundjeri land as we speak, and I'd like to pay my respects and acknowledge the Wurundjeri traditional elders and custodians of this land in the past and the present, and to everyone else who is here today of Aboriginal and Torres Strait Islander descent. I'm really excited to be able to come talk to everybody about some work we've been doing for quite a few years, and to center the voices of the elders and people that we've been working with over the years. So what I'm going to do is try to share my screen. I think this will work out.
You were recently contacted on behalf.
Being a bit slow, come on, there we go. Can everybody see that? There we go, all right. So my name is Duane Hamacher. I'm an associate professor of cultural astronomy in the School of Physics and with the Astro 3D Center of Excellence here at the University of Melbourne. My specialty area, as it were, is looking at astronomy in a cultural, historical, and social context, looking at astronomy heritage, looking at things like dark sky studies, and even the history and philosophy of science. I've been working primarily with communities by invitation here in Australia, mostly on the eastern coast, and in particular in the Torres Strait, where I've been working with Meriam community on Mare for about the last 7 years, and been very fortunate to have learned quite a tremendous amount. Well, I think overall a small amount, but for me, quite a tremendous amount of their star knowledge over the years, which we're working to put together for community benefits and education programs and overall cultural preservation. Because colonization has been such a damaging force here in Australia, there are many places where the knowledge has been fragmented. Some places it's still going very strong, and other places only a few elders have bits of knowledge here and there. So the communities are inviting us to work with them, to interview the elders, to go through the archives, try to bring everything together and try to make sense of it so the community has a more complete and better picture of their overall star knowledge that they guide and can decide what they want to do with that. So what I'm going to speak about today and tomorrow all focus on indigenous astronomy, and I use indigenous as sort of a double meaning. Yes, it is the astronomy of Aboriginal and Torres Strait Islander people, but it's also the indigenous astronomy. It's the first astronomy. It's the astronomy that was around before Western science and developed independent of Western science. And one of the things that we're going to focus a bit on today and tomorrow are some of those layers of knowledge that we would consider to be very scientific. And we're going to talk about, in particular today, how that relates to seasons, weather, and animals, and predicting seasonal change, forecasting weather, and understanding the behavior of animals by looking at changes in the positions and the properties of the stars themselves. Of course, this knowledge is passed on through, I'll get my thing to work, through orality. Literacy on a global stage is quite recent in human history. But there's this really bizarre negative idea that if something is written down, it's law, but if it's not, it's hearsay. And that there's some kind of, I don't know, worship of the written word, as it were. But most cultures of the world in the past and even the present use systems of orality. That means handing information down through oral tradition, through song, dance, story, art, in different ways. And that utilizes something called the method of loci. And that's the process by which the human mind is actually developed to associate memory to place. We're going to talk more about that tomorrow. But today I just wanted to put out there that, the information that the elders are giving, sometimes the elders just sit and start talking to me like a university professor. Sometimes they talk about the stories and the traditions. And I'm going to feature some videos of elders whom I've interviewed and I've just spoken to the last few days, and we're very happy for me to share this knowledge with you. But I'm going to show you how some of these stories encapsulate and encode this scientific knowledge, this traditional knowledge, how that's also relayed in song and dance, and how that's, developed through craftsmanship and social practices. So what does it mean to be an astronomer? I'm an astronomer. I know lots of astronomers, but if you ask us what constitutes an astronomer, you get kind of a very broad and somewhat narrow definition. Somebody who studies things in space or outside the Earth's atmosphere. There are lots of different types of astronomers. There are those that are observational, so they look through telescopes, whether they're optical telescopes or radio telescopes. There are those who focus more on theory, which is mathematically based. There are those who study the planets, which is more geology based. There's a lot of different areas that are encapsulated in astronomy. In the past, astronomy has been the study of everything outside the Earth's atmosphere, but also an astronomer was somebody who looked to the stars, somebody who actually physically observed the stars. And you have a role of astronomer in many cultures around the world, including many indigenous cultures. Here in Australia, in the Torres Strait, that person's called the Zugabul Mabayig, which literally means star person. And we're going to talk about how that's, where that name actually comes from in this lecture. But this is a lino cut by David Bozen. David Bozen is a famous Moa artist. So Moa is one of the largest islands in the Western Torres Strait. And David's been phenomenal. He's a treasure trove of information. His father was a traditional navigator in Zugabul Mabayig. And he's met with me a great many times and shared some of the star knowledge of the Western Torres Strait. And I'm going to be featuring a bit of that in our talk today. He talks about the role of the Zugabul Mabayig was considered one of the most sacred and important roles in the culture, because this is a person who sat out every night and observed the stars. He observed the positions of the stars, the positions of the planets, the sun, the moon, how they change, changes in the properties, how do you read those properties. This was important for knowing how to practice agriculture, how to garden, how to fish, hunt, when to hold ceremony, when to know when the weather was going to change, when to know the seasons were going to change, how to predict the behavior of the plants and animals. All of that is tied in to the job of the Zugabul Mabayig. And this is not something that's just unique in the Torres Strait. You do find this with the Aboriginal cultures around the country. Now, we're not going to have a humongous amount of time to go and do a full in-depth study of positional astronomy, but there are a couple things I'd like everybody to know. I'm not sure how many people have studied astronomy, whether it was in primary or secondary school, or maybe even at the university level. But when we look up at the sky, we notice a few different things. We obviously have the sun during the day. The moon can be day or night, going through its different phases. We see the stars. And we notice properties about those stars. We notice their brightness, we notice their color, and we can notice even sometimes they might be doing things like twinkling. Sometimes there'll be a bright lone star, sometimes there'll be stars in groups or clusters. We'll see the Milky Way in the sky, the big band of light, and we'll even see little dwarf galaxies nearby called the Magellanic Clouds. Those you will see from the southern hemisphere, but you will not really see from the northern hemisphere. So that's something that's very unique down here in the southern skies. But the stars rise in the east and set in the west at a very particular point on the horizon. That point on the horizon is called the azimuth. This is the angle around the horizon. So the azimuth goes from 0 to 360 degrees, starts at 0 at the North Pole, the celestial north, 90 degrees east, 180 degrees south, 270 degrees west, back to 360 or 0 degrees at north. And this is something that we're going to discuss more tomorrow in our discussion about celestial navigation and star maps. But every star rises at a particular point and rises at a certain time of the year. So as the Earth goes around the sun and as it turns on its axis, all the stars do a full loop every 24 hours, but that shifts as the Earth goes around the sun. And what that means is we're going to be looking very specifically at one particular property of the stars in the first part of this lecture, and that's when they rise or set at dusk or dawn. Sometimes a star will set just behind the sun. So you look to the west, you see the star setting, you see the sun setting, and just as the sun goes down, the stars come out. And there are going to be some that are in the west. They're going to be visible for a very short time before they set below the horizon. Sometimes you're going to see stars rising at sunset. So those that are either rising or setting with the sun, we call heliacal rise or heliacal set. Heliacal simply referring to Helios or the sun. If those stars rise or set opposite of the sun, we call a chronicle or opposite of the sun. And if those stars happen to be at the highest point in the sky at dusk or dawn when the sun sets, we call that the meridional crossing. Now, this is going to make more sense when we start getting into our practical application with stellarium. But the meridian is an imaginary line that connects the north and the south, goes straight over our heads. Anytime an object crosses the meridian, that is when it reaches its highest point in the sky. So here on our graph, we can see the dawn meridional crossing. This is in the morning when the star is at its highest point. This is when a star rises at sunrise opposite the sun or with the sun. So we're going to have some more practice with this. And what we're going to do is we're going to utilize this program called Stellarium. So everybody needs to download this piece of software. We're going to take a break after the first hour for about 5 or 10 minutes before we come back in. But we're going to spend the second half of our time today, the second hour, really working with Stellarium to see this stuff in action that we're going to be talking about during the first part of the lecture. Stellarium is an astronomy and planetarium software that you can download for your phone, tablet, or laptop, whatever device you have. You can get it for free. It can show you exactly what's in the sky, any time of the day, any year, from any place on the Earth. So you can put yourself in Melbourne, you can put yourself in London, you can put yourself anywhere you want, at any time, any day, about plus or minus 10,000 years into the future or into the past. You get beyond those levels and the accuracy of our data starts to decrease a bit. So what you see on that program might not be entirely accurate. But the point is you can see anything in the sky from any time, from any place, thousands of years into the future or into the past. You can see the phases of the moon, where the planets are going to be, what the positions of the stars are, and you can zoom in to quite some depth. You can actually zoom into the planets and see the moons orbiting those planets. You can zoom into distant galaxies. It's a tremendous wealth of data and information that is at our fingertips, and this is going to be what we utilize a lot of today. So let's start getting into some of the more interesting aspects of this. When stars rise or set at dusk or dawn throughout the year is a common seasonal indicator for Aboriginal and Torres Strait Islander people and different cultures around the world to mark things like seasonal change and the behaviors of plants and animals. So for our first example, we're going to go to Boron country. This is in northwestern Victoria, up in Mallee country near Lake Tyrrell. That area is commonly known as Mallee scrub, and this is the Mallee hen, or the Mallee fowl. And the traditional Boron name, the Wachabalic Regaya language, is called Loan. This community, the Boron community, prided itself on knowing more about astronomy than any other community around. They prided themselves on being the star experts when it came to Victoria, New South Wales. At least they said that. And every evidence we have is they're amazing astronomers, and we're still, Western scientists are still discovering new things about Western science based on the records of these cultures that were recorded back in the 1850s. So at the time, there was an Englishman named William Stanbridge who took up Tyrrell Downs, management of Tyrrell Downs, and he got to know some of the local Aboriginal people. Unfortunately, we don't know the names of any of those people in the historical records, and that clan, the Boron people, don't seem to exist as an independent entity, but they are part of the Wachabalic Regaya Nation. But two individuals in particular sat down with William Stanbridge over time, and they explained to him a bit about their star knowledge. And he published it in 1857. This is the first detailed written study that we have of Aboriginal astronomy in Australia. It is very much written from his perspective, which has its own various problems, of course, but it gives us some insight into some of the early views of astronomy from Aboriginal people here in Australia, at least post-colonization. The people talk about Loan or New Loan being related to the star Vega. The star Vega is in the constellation Lyra. And the people say that when the eggs are coming into season on the Earth, they're going out of season with Niloan. When she sits with the sun, her eggs are in season. So let's unpack that a bit. What are we talking about here? So Loan, the Mallee fowl, is called a megapode. This is a mound-building bird. And it's about the size of a chicken. And what it does is it builds these mounds you see up in the top left corner here. In the bottom of it, it puts sort of dead, rotting vegetation. It lays its eggs on top of that vegetation, and then it covers the eggs in sand. Rotting vegetation creates heat. The heat incubates the eggs. The sand on top helps to insulate the eggs. And the beaks of the birds are very sensitive to temperature. They can put their beak inside the sand, and they can tell if it's too hot or too cold. If it's too cold, they kick more sand on top. If it's too hot, they kick sand away. And that's how they regulate this. There's only 2 or 3 species of megapodes. The Australian brush turkey is another one, here in Australia anyway. So what we find from this is when Vega rises at dusk, this is August. This is when the Mallee fowls, the Loans, begin building their mounds. When Vega is high in the sky at sunset, that's when they begin actually laying their eggs in these mounds. And when Vega sets at dusk later in November, that's when the eggs are ready to be collected. So it's not just one point throughout the year. It's not just when it rises. It's when it rises at sunset, when it's high in sunset, and when it sets at sunset. So you see the close link between the behavior of the animals and the stars. And this, of course, was utilized. There's lots of stories about the Mallee fowl and how it interacts with other animals. And these stories are meant to encode information about the behavior of the animals and to be able to understand that and to predict when you can collect certain food sources. So essentially, this is a bit of food economics here as well. Now, what we see here is a beautiful image of the Milky Way galaxy. You're not going to see it very well from the cities, of course, but if you get out into the country, it is quite stunning. Right here is the very center of the Milky Way galaxy. This is often called the galactic bulge, and it sort of trails off on either end. So the Milky Way, in Western science terms, is a giant disk of about 200 billion stars, many of which have planets, lots of gas and dust, all spinning like a giant disk. And we're in that disk looking into the center right here. You see this bright red star? This is the star Antares, which will come up again later in this lecture. This is the heart of the scorpion in Greek traditions, as well as other indigenous traditions around the world. You can see the shape of Scorpius right here. In many cultures in Australia and the Pacific, this is actually seen as a canoe. And you look over here, you see these two bright stars. This is Alpha and Beta Centauri, or Rigel Centaurus and Hadar. They're called the pointer stars because they point right at the top of the Southern Cross, or Crux Australis is the Western science name of that. This is very prominent in Aboriginal and Torres Strait traditions around the country. We're going to talk about a couple of those today. But what you notice about the Milky Way itself when you're looking in, you see areas of bright gas and dust and nebula and stars, but you also see these dark dust lanes. These dark dust lanes are areas of cool gas and dust that are obscuring the background light of the stars. It's not that there's nothing there, it's just like smoke, it's obscuring the background light. And these dust lanes trace out a number of different animals that you're going to see in different Aboriginal traditions around the world. For example, right here in Gamilaroi and Uwalyi traditions, it's seen as a kangaroo. In some places, this is a cave. It's the coal sack. But what you do find all across Australia is a very famous constellation traced up by these dark dust lanes, and that is the Emu in the Sky, which goes by a whole range of different names. We'll talk about a couple of those. Now, the Emu in the Sky, like I said before, is a dark constellation. It's a constellation made up by the dark spaces between the stars, not the bright stars themselves. There are many examples of this across Australia and around the world. And in fact, this month, colleagues and I are just publishing a paper comparing these different types of dark constellations around the world. So it's going to come out online at the end of the month. I'm actually looking at the final review of it right now, but you see these kinds of patterns from different cultures around the world and around Australia. In Australia, it's very commonly associated with the emu, and the position of the emu in the sky, depending on the time of year, is going to change. And its meaning will actually change depending on where it is in the sky. But the emu itself informs seasonal change, it informs food economics, and it informs the behavior of the animal itself. So let's have a more specific look. This knowledge that I'm going to tell you about comes from the Uwalyi Nation. Gillar Michael Anderson is a senior Uwalyi elder who's been working with our group for several years and sharing knowledge about his people. He's been a co-author on many of the publications on this topic and is involved in helping us develop some curriculum content around this as well. And what he taught us is that the meaning of the emu in the sky changes throughout the year. So we're going to look up in the sky at sunset, just after sunset when the stars come out. In the top left corner, in the A frame, this is about April, May. This is when you first see the full emu above the horizon at sunset. In Uwalyi and Gamilaroi traditions, this is seen as a female emu. The female emu is running. And the reason that she is running is she is chasing a mate. So with the emus, it's the females that chase the males to mate. And she does this sort of strange dance where she circles around him and kind of loops in until they do their thing. So this is the main season where the emus begin breeding and they begin to build their nests. By June and July, the emu in the sky is sort of horizontal above us. It's sort of like we see in this picture, right across the sky. And that's what we see in figure B. At this point, the emu is no longer female running, but now it's a male, and he's sitting on the nest. The males are the ones who incubate the eggs, and the incubation period is about 58 to 59 days, so approximately 2 months. And people ask, well, why are the males sitting on the nest? Well, nature isn't just binary, as we like to think humans can be. Those emu eggs are extremely large. They can hold up to a dozen chicken eggs. They're very, very big. And the female can lay several eggs in a clutch and several clutches in a season. She can lay up to 25 kilograms of eggs in one breeding season. Now think about the energy expenditure it requires for her to be able to produce those eggs. When the males sit on the nest, they don't move for 2 months. They only move if they absolutely have to, like to defend the nest. But for that 2 months, they fatten up during the autumn, and they sit on those eggs for the entire time. If the female did that, she'd die. The animals wouldn't survive because she's not able to produce all of those eggs and expend all that energy and then sit on the nest the entire time. So a bit of biophysics that goes along with this as well. In frame C, this is coming into spring. So this is coming into August and September. Now the emu in the Milky Way is perpendicular to the horizon at sunset. It's now seen as a male getting up off of the nest. The reason he's getting off the nest, of course, is because the chicks are hatching. It is the male's responsibility to look after and rear the young. And this is reflected in some of the initiation ceremonies of the Gamilaroi and Uwalli. Now, obviously, I'm not going to go into any detail about those, but I'm going to share one little bit of public information about them. Many of the initiation ceremonies are called Bora ceremonies, B-O-R-A. And this is a ceremony in which young men and women are taught the traditional laws and stories and traditions, and they have to recount that and go through a period of ceremony. The Bora grounds themselves are seen as two large circles. There's a very large circle, which is a public circle, and a smaller circle some distance away where the initiates go with the very senior elders, and then secret business happens there. There's usually a pathway connecting the two areas. That Bora ground on the earth is reflected as a Bora ground in the sky, and is reflected in the same part of the Milky Way as we see the emu. In fact, it looks like this. The body of the emu is the large circle, the head of the emu is the small circle. And the orientation of these Bora grounds were done in such a way that they actually pointed to the Bora in the sky when we see it. So the large circle, imagine you're behind your computer, you're sitting in the large circle, the small circle's in your laptop, and you look straight up, and that's where you're going to see the Milky Way at sunset connecting the land to the sky. So there's a symbolism there of the men bringing the boys into manhood, just as the male emus are bringing the chicks into adulthood. As the year progresses, we see the emu keep flipping around down low in the horizon. But even though on here we can see this is the head of the emu and this is the neck and the body. So why now does it look like the bum of the emu is sitting on the horizon? Well, Uncle Gillard teaches us that in Uwalli and Gamilaroi traditions, that they see this as the bum of the emu, not the body. And it's the emu sitting in the water holes. And as it sits in the water holes, it's trying to cool off because the weather's getting hotter and hotter. And when it sits in the water holes to cool off, it displaces the water, which spills out and comes falling down as rain. It sort of peaks around November coming into December. So you can see from this really low level of knowledge here compared to what the knowledge levels really are with these cultures. This is sort of still very low levels. We can see that it tells you about the behavior of the emu. It tells us about seasonal change, and of course, when to collect eggs. You want to collect eggs really in about the late autumn and very early part of winter. You go much beyond that, you start getting chicks in the eggs. So we saw the bone of the emu sitting here. Well, how does, let's look at this in practical terms. This is Lightning Ridge. This is up in Gamilaroi Uwalli country. If you look at this graph, it tells you about the high and low temperatures throughout the year, and it also shows you the mean monthly rainfall. And what you notice about this is there's a huge peak, a jump in the rainfall from October into November, where it's the highest in the year in November. This is the time of the year that we see the emus sitting in the water holes displacing the water, like a celestial Archimedes. Now, the emu in the sky is found all across Australia, and the Royal Australian Mint about 2 months ago released a new commemorative coin. I forgot to mention before, sorry about that. Gawargay is the name of the emu in the sky in Uwalli and Gamilaroi traditions. The emu on the ground is called Duane, but in the sky it's called Gawargay. This emu coin features the artwork of Scott Sauce-Towney, a Wiradjuri artist from Peak Hill, New South Wales, and in Wiradjuri culture it's called Boogerman. Very similar meanings that you're going to find in Gamillar and Yuayi traditions, and of course similar traditions around Australia. Interestingly enough, this same shape in the sky is related to a very similar bird in South America with very similar types of traditions. This bird is called a rhea. It looks very much like an ostrich or an emu. It's closely related to both birds. You find this down in the southern half of South America, and the Quechua people and different cultures have different names for it. But this rhea is seen in the sky as a very similar shape. Same part of the Milky Way as the emu. The bird has very similar behavior patterns to the emu, very similar breeding patterns, and you find remarkable similarities in those traditions between those two cultures. So now let's jump up to the Torres Strait. This is the archipelago of islands between Cape York Peninsula and Papua New Guinea. There are about 17 Torres Strait Islander communities spread across the straits. This island here is Mo. This is where David Bozen is from. He's the artist who drew the Zugabon Babaig artwork. Mer out here, this is where I've been working with the community for many years. The Mer people, this is the home of Eddie Kweki Mabo, which most people will be familiar with. And down here, these southwestern islands, these are the Gawareg people. Even though it's in the Torres Strait, they actually identify as Aboriginal people. It's these islands up here that refer to themselves as Torres Strait Islanders. In the Torres Strait, one of the main ancestral figures and constellations in the night sky is called Tagai. And the elders have taught me, this is the Marian version of it, is Togai in the western Torres Strait, the northern Torres Strait, and the eastern Torres Strait with the Marian Mir people, it's Tagai. Tagai was an excellent fisherman, a great warrior, very prominent individual in the community. He had a crew of men that would go with him on various expeditions. He had a first mate. Some traditions say he was a first mate, some say he was actually his brother, named Kareg. And in the Western Islands, his name is Kang. And he had a crew of 12 men called Zugabuls in the Western Islands. So these 12 men, Tagai and Kareg, once went out on a fishing expedition onto the reefs. It was a hot day. They had prepared to go out for a few days. They had no luck catching anything, so Tagai walked out onto one of the reefs trying to find a better fishing spot. The crew, the Zugabuls, back on the boat, just grew sort of bored, tired, hot, hungry. They began consuming the rations. And before too long, they had ended up consuming all of the rations, including those of Tagai. Now, Kareg was very upset and warned them against this, but they didn't pay much attention to him. When Tagai returned, he was livid, as you can imagine, so livid that he flipped out in a complete rage and he killed the 12 men. He cast them into two groups of stars. One side, the port side, he cast into he tied them up, threw them overboard where they drowned, and cast them up into the sky where they became the stars of Usian, or the stars in the cluster we know as the Pleiades. And the other group, the starboard side, he threw in the water, cast them up into the sky where they became the stars in the belt and scabbard of Orion, or Seg. In the Western Torres Strait, it's Utiam and Usamon. Tagai and Kareg went up into the opposite side of the sky, where Tagai stands as a very large constellation, and all the different stars trace out his body and his hands. So he's standing high with his arms stretched out, holding a giant spear. His left hand is the Southern Cross. His right hand are the stars in the Western constellation Corvus the Crow. You see stars tracing out his elbows, his arms, his shoulders, his eyes, mouth, belly button, his male parts, and even his legs and feet. He's standing in the canoe, which is the stars of the Western constellation Scorpius. So I mentioned before, this constellation is often seen as a canoe in mostly northern Australia and the South Pacific. The bright red star, Antares, is Kareg. That's his first mate. Tagai stands at the bow of the canoe. Kareg sits at the stern of the canoe. When Tagai, this very dominant constellation in the sky, rises and sets throughout the year, it signals the change of the seasons, which are dominated by trade winds. Some of the main seasons being the Sager, which is the cool, dry season, dominated by southeasterly winds, and the Kuki, which is the hot monsoon season, denoted by northwesterly winds, and a transitionary period called the Nege. So when Tagai rises and sets throughout the year, also corresponds to when the Usium and Seg stars rise and set throughout the year. And Usium and Seg were placed on the opposite side of the sky of Tagai because he was so angry with them, he wanted them completely away from him, which is sort of similar to the Greek traditions of Orion, because Orion, which are the stars in Usium or Seg, as we mentioned before, actually fought the scorpion and stabbed the scorpion and killed it during this battle. And the gods placed on the opposite sides of the sky to keep them away from each other, with the scorpion as a canoe of Tagai. So you find these remarkable similarities in traditions and star traditions all around the world by different cultures separated by space and time. Now what we have here is a fantastic little drawing that Uncle Sigar Passy, he's a Dalrab man, which means he's from the island of Dawar, one of the two small islands near to the larger island of Murray Island. And he's a senior Miriam elder on the island. And what he did here, this is actually an initial drawing for a coin that we were going to design. He's got a completely different design for that coin now, which is going to come out next year as part of this series that I mentioned before. The first one was the Emu in the Sky. The second coin comes out the end of this month with the mint. It's for the Seven Sisters and Yamaji Wajari traditions of Western Australia. In the middle of next year, Uncle Sigar has got a coin coming out. I can't talk too much about it right now because it's a bit of a secret, but it's going to feature a beautiful artwork of a very special animal in the stars in Merian traditions. But this was a fun initial little draft he made up, and I love this, and I wanted to show it to everybody here because of its significance. Uncle Sigar is a world-famous artist. He's got this amazing ability to create the most amazing artwork with a palette of colors that I've never seen. Every brushstroke, every design, every motif has special significance, and it tells you deep layers of knowledge. What you see in this initial coin design is the island of Dawar. This is Al Passer. This is the big hill on Dawar. You're looking from the tip of the peninsula. So I'm going to show you right here. These are the three islands of the Murray group. This is Mer, Dawar, and Wair. So the community used to live, the Dalrab used to live on the island, but were moved to the mainland by the government like 50 years ago. But that perspective you see right here is if you were standing right here at the tip of this peninsula looking down this way. There's a very big hill right here called Al Passer, and this little sand peninsula coming down is where the community used to live, or one of the communities used to live. Now, when you look up at sunset, you're going to see the Southern Cross setting over top of Al Passer. If you remember from before, the Southern Cross is the left hand of Tagai. So Tagai is holding up a spear out of these two hands. This image you see here is actually slightly different. This is from the Western Torres Strait, where they have a slightly different view of it. In the Meriam traditions, both hands are holding a spear, and the prongs of the spear are seen by the stars here in the constellation Musca. But he says, when Tagai spears Al Passer at sunset, that's when the turtle breeding season begins. The turtles love breeding on this sandy peninsula right up through here. I was very fortunate to have been taken there by a couple of elders a few years ago, where I had to stand in one little spot and couldn't move from that position. But it was absolutely gorgeous there. When Professor Martin Nakata took me here for the first time, he described this as a place where serious business happens. So I was deeply honored to be shown that place and taken there, even for a very brief time. So you can see again with Tagai, Usium, and Seg, when these stars rise and set throughout the year means different things. It signals behavior of animals, it signals seasonal change. And even towards the end of the year, when Usium and Seg dive into the sea, they set at sunset, the people see those as splashing into the water, and the water splashing up comes down as the monsoon rains. Now, something else a little bit differently, we talked about the properties of the stars, or I briefly mentioned how Aboriginal and Torres Strait Islander people read the stars. And when I mean read the stars, we've looked at how they observe the positions of the stars rising and setting throughout the year. But what are the other properties of the stars we see? Two of the main properties we see are the brightness and their color. In Western astrophysics, astronomers have set up a classification system about stars based on their color. It's part of the Hertzsprung-Russell diagram for anybody who's actually studied astrophysics before. But they come in different classes. Class M stars are your redder stars. These are relatively cool. They're about 3,000 or 4,000 degrees in the surface, and they get hotter as they get more blue. And the bluer stars are the hottest ones. They're like 8, 10, up to 50,000 degrees. Stars like our sun are about 6,000 degrees. As it turns out, Aboriginal communities have their own stellar classification system based on color. So the Lurcha people of the Central Desert have their own classification system where they describe them as being generally either Antarctica, red, or Jokera, white. So the ones like the sun, which are kind of reddish white, they call Antarctica Jokera, simply a combination of those two words. And the very few stars in the sky that are extremely red, like Antares or Betelgeuse, those are called Antarctica Andorra, or very red stars. Those stars are extremely rare. Only 3% of the stars in the sky that we see fall into this category of Antarctica Andorra. There's even fewer of those that are very bright that we can see, literally only a handful. And some of them include Betelgeuse, Aldebaran, Antares, and Gamma Crucis, the top star of the Southern Cross. The bluer and whiter ones are far more common. And what this means is that Aboriginal and Torres Strait Islander people and Indigenous cultures around the world link those colors to particular animals that reflect those colors. So for example, Kagalongo, this is the red-tailed black cockatoo. These are from the Kokatha and Rangu people of the Great Victoria Desert near Ulia, South Australia. This particular bird is linked to both Mars and Antares. These two stars are bright, they're very red, they come close to each other in the sky at different times, not just throughout the year, but as the planets orbit the sun. Sometimes they come very close. And that's actually reflected in the Western names of these two objects. Antares means the rival of Ares, or the anti-Ares. Ares in Greek mythology was the Greek god of war, fire, blood, destruction. The Roman god of war is Mars. So they're actually rivals to each other. Because the path of the solar system goes through Scorpius, which is why Scorpio is one of the constellations of the zodiac, these two objects sometimes come close together, and those are described in Aboriginal traditions. Unfortunately, because of this, early anthropologists, ethnographers, missionaries working with Aboriginal communities or learning from them didn't know their astronomy very well. The elders did, but the ethnographers didn't. And what the ethnographers wrote down in their books and journals were a lot of misidentifications. And these misidentifications are now being picked up, and it's revealing deeper layers of knowledge that Western science never recognized. And in fact, discoveries made by Aboriginal people that predate those of Western science. One of those examples is of the Ngarrindjeri people of South Australia. This is the people along the Coorong, south of Adelaide. This is the mouth of the Murray River. The people talk about Wayangari. It's a very famous star in the sky. I'm just going to share elements of the tradition to give a context of what it's about. I'm not a storyteller, and I'm not here to share other people's stories. I'm just here to give a context of what these are about. I have spoken to some of the artists and community members over there who've told me a bit about the story, as well as what I've seen written by anthropologists in the past. And some of the stuff the anthropologists wrote down was wrong. And we're going to talk about what that is, why that's important, how that relates to seasonal change and the positions of stars. So in these traditions, Wayangari means red man. Wayangari was a young man, an initiate, going through initiation. He had to go through a sacred period of being Narambi. And Narambi is a period of initiation where you have to make significant sacrifices. And one of those means that he has to go through a period of time where he has to fast. He's not allowed to eat. He's not allowed to have contact with anybody. He can't wear any clothing, and he's covered in red ochre, hence the name Red Man. And it's extremely taboo for him to have any contact with other women. So as he was going through this period of time, he was walking along a riverbank, and he bent down to get a drink of water through a reed as a straw. And as he did that, some of the ochre fell into the water and began washing downstream. Two women downstream saw the ochre, and they were wondering, where's this coming from? They snuck around, and they saw Wangari. They thought, it's pretty hot. So they followed Wangari back to his home that evening. When Wangari went into his home, they morphed into emus and made sounds like emus to draw him out, because he was a hunter. So he come running outside ready to attack the emus. The two women morphed back into humans, and the three of them went into the hut, and I'll let you draw your own conclusions as to what happened. The point being is he broke two sacred taboos. Number one, he wasn't supposed to have contact with women during this point in time, and those two women happened to be the wives of his brother, Nepali. So when Nepali found out about this, he became enraged and decided to exact his revenge by setting the home of Wangari on fire while he and the two women were in it. They managed to figure out what was happening, escape, and in a bid to escape punishment by death, he threw a spear into the Milky Way, where he pulls himself and the two women up into the Milky Way, where they sit as a bright red star, which is Wangari, and two stars on either side, which are the two wives. This star, this group of stars is high in the sky in the springtime, and it signals the breeding season of all the animals, the normal stuff that happens in the springtime. And it serves as a warning to people, because Wangari on occasion will get hotter and brighter and then fade a bit dimmer again. And the people say, the Narrandera people say, that this is Wangari telling people, warning people not to give in to their carnal urges, because it's his sexual energy that's increasing. So this star appears, like I said, high in the sky every year in the springtime. And it describes these stars as sitting in the celestial canoe to the west of the great Emu. Now, early anthropologists wrote this down and said, oh, well, it's red, it's in the sky, therefore Wangari is Mars. And that's been repeated through all the books and literature by these so-called anthropologists for a very long time, and it's totally wrong. Does anybody know why it's wrong? Can anybody guess why Wangari cannot be a planet? I don't know if anybody's going to jump in or not, but the reason it can't be is because a planet literally means wandering star. They move around in the sky. They don't stay in the same place. So Mars is never going to appear high in the sky in September at that time of the year they're talking about. Sometimes it's going to be there, sometimes it won't. It doesn't make any sense. What happened is the anthropologists wrote it down wrong because they didn't know their astronomy. It's actually the star Antares. Again, in the celestial canoe, the canoe of Tagai, the canoe you see in the South Pacific. Wangari is the bright red star Antares, and the two women on either side are Tau and Sigma Scorpii. They're in the great celestial canoe, and as you remember, in this direction, going towards the bottom of the image, is the great celestial Emu. This star appears high in the sky and about sunset in September. So this fits very nicely, but why is it important? What is it that the anthropologists missed? What is it that changed the history and philosophy of science? As it turns out, Antares is actually a variable star. It changes in brightness over time, but it wasn't known as a variable star until the late 1800s. Well, Aboriginal people had already known long before that this star changed in brightness. It's Wangari brightening and then fading again over time. So this realization shows, it's sort of very late on the part of Western scientists and anthropologists, but Aboriginal people already knew about this. They already knew about these observations and made this who knows how long ago. And this is not the only example. In fact, in the Uldia traditions, they describe the stars Betelgeuse and Aldebaran also changing in brightness, battling back and forth between two characters in the sky. It also talks about their relative periodicity. So this just gives, it's just another layer showing the keen observation and how that knowledge of these keen observations was passed down over time in such a way that people could make these long-term observations without the information degrading. This seems to be a surprise to some people, some Western scientists and some amateur astronomers. They told me I was full of crap, this wasn't right, but the evidence is there, the people tell us it's there, of course it is. Just because people are too racist to think somebody else could figure this out before they did, doesn't mean that it's wrong. So the last thing I'm going to talk about before we take a break and come back, it links to agriculture in the Torres Strait. And when I first went up to Mayor, I was invited to work with a few elders in particular. One of those elders is Uncle Allo Tapham. Uncle Allo Tapham is one of the senior Dalrab elders there on the island. He's a wealth of knowledge. He's trained as a linguist. And just recently in the Queen's Awards, he was recognized with an OAM. And Marcia got an AO as well, which is fantastic. So what I'm going to do here is I'm going to play a video of Uncle Allo talking about how he observes certain types of astronomical phenomena and how that relates to gardening. Because Uncle Allo told me that he is a gardener, but his brother Baymop, who lives next to him, he is a fisherman. So if I wanted to ask about fishing, I had to ask Baymop, which I did. But Uncle Allo was teaching me about agriculture and gardening. Let's hope this plays.
It's very signs that season change. You see in trees and gardens, but mainly in the stars. It's become quite apparent towards the end of the year when you get the very clear sky. Hot days during the night because there's no clouds, and same throughout the night. And the stars are there. The stars are very clear, all colorful. And when they twinkle, it heralds whether there's going to be, whether wind will pick up. And fishermen sort of capitalize on that. It gives them a fair idea that they will have a good day out at sea, or they can overnight at the reef, come back the next day by observing these stars. But especially from spring into summer, you get that dry, hot season where there's hardly any cloud up in the sky. There's, I don't know if you, I think the word doldrum, which is very fine, not a breath of air. The air is still, not in motion. During the night, where the dew sets in, you see that stars. The stars are, they're really out shining and they're twinkling. And it's a good sign. It tells that it heralds the changes in the weather. Instead of that hot, dry season, there is a wet season that's coming through. And locals always look forward to that part of it. They observe the stars because the gardener is anxious. When my plants are in, when is that rain going to come? And they observe stars, the plants, and the path of the sun. And at night, they are aware that there is a dew, even though there's a hot sun, the coolness of the dew goes right into the dry ground. Even though it may look brittle on top. But when a farmer digs down, it's cool and it's sort of muddy inside. And it's a result of the dew. Dew keeps the soil inside. Maybe a baby cicada or something not fully developed. The farmer will bring that out just by observing that cicada. He said, the wet is near. So by observation from the ground, from the environment, even from the sky at night, the farmer is reassured by all these signs that it's only the temporary. There is a tomorrow. There is a rain. There is a rainy season. You're not going to miss out altogether.
Okay, so what I'm going to talk a little bit more about what Uncle Aloe is getting into regarding the twinkling of stars. But we're at 1 o'clock now, so I think what we'll do is we'll go ahead and take about a 5-minute break. Everybody come back in 5 minutes and we'll kick it off again. If you haven't already, please download Stellarium. We're going to do a little bit more of the lecture, then about the last 35, 40 minutes, we're going to do some exercises utilizing Stellarium. So everybody want to come back in about 5 minutes and we'll get going again. Kicked it back off again. It's recording now. I've got it back up again. Thanks for that, because I want to make sure I get everything. All right. We are recording. We're back. Excellent. So, played the video of the twinkling stars and changing seasons with Uncle Aloe Topham explaining what it means, how he utilizes that for gardening. Other elders in the island and communities from around the world also observe the ways the stars twinkle. Like I just said a minute ago, this should actually be reviewed for you because this is one of the readings I put up on LMS for this particular lecture. Is a paper that we published with several of the elders on Mare about indigenous use of the twinkling stars or stellar scintillation. Scintillation is just the technical term for twinkling stars. But the elders, have been teaching me how you can read the way the stars twinkle to know things about the weather and the seasons. For an astronomer, that was something fairly new to me because in astronomy and astrophysics, the twinkling stars is a problem to be overcome. When you're trying to get accurate data through telescopic observations, you don't want the stars twinkling, you want them to stay as still as possible. That twinkling is caused by turbulence in our atmosphere. So, that's why we put telescopes at the tops of the highest mountains or spend billions of dollars putting them in space like the Hubble, because you want to get away from that effect of twinkling. But a totally different perspective is seeing it from, the view of Torres Strait Islanders and Aboriginal and indigenous people around the world. It's not a problem to be overcome. It's a very important part of nature that you observe that can tell you a whole lot of things if you know how to read it and how to interpret it. So the elders were teaching me that, there are certain types of stars you look at, whether you look at them and how the stars twinkle are all very important. First off, you look at stars that are high above. You don't look at low stars, you look at top stars. And Uncle John Barsa, who unfortunately passed away a few years ago, his family has been very happy for me to continue sharing his knowledge with the public that he gave me permission before he passed, and then of course his family has been happy for that tradition to continue. He's been a co-author on many of the publications we've put out on Marian astronomy. He taught me that you need to look at the stars that are high above, because the lower those stars are on the horizon, the more affected they are by our atmosphere. When we look straight above us, directly above is called zenith. That's the thinnest part of the atmosphere. But as we look down lower in the sky, we're actually looking through a thicker part of the atmosphere. It's like a layer that goes all the way around. But when we're looking at it from this angle, we're actually looking at a thicker part of it. The thinner part is straight above us, if that makes sense. Therefore, it's going to be less affected by turbulence in the atmosphere. You're going to get a more accurate reading of the stars if you look at them high above. He also says that you look at the brighter stars. The fainter stars are more susceptible to scintillation. The starlight is weaker in flux, therefore it's going to twinkle more easily. So you want to look at those brighter stars that are high above. And the indigenous views of the twinkling stars, the Western science views of the twinkling stars are exactly the same. They're caused by air turbulence. So as pockets of air are moving around in the atmosphere, those little air pockets have different temperatures and different densities, and they cause slight changes in the refraction of that starlight as it comes through, and that causes it to slightly change in brightness. So it sort of flickers back and forth in brightness. And that tells you about wind movement and air movement. So in the straits, as Uncle Allo was alluding to before, you look at how the stars twinkle. When they're twinkling really quickly, you know there's a lot of wind movement. So you also look at the color of the stars. Do the stars appear very blue? Now this, initially, when I was learning from the others, I thought was quite peculiar. I thought, well, blue is not a color we see very well at night because the way our eyes adapt to the dark, the color-sensitive cones stop working and we're left with the sort of black and white, light and dark sensing rods around the periphery of our eyes. So blue is not a color we see very well at night anyway. So why would the stars appear very blue? And then it dawned on me why, and I'm going to show you something in just a minute. But before I get to that point, Uncle Allo told me that the Marian people passes knowledge of the stars, of the twinkling stars, down in many ways. One of them is through a song. And the song is called Huer na Skaisreda. Huer is the Marian name for a star. In the Western Torres Strait, the Kalalagoya language and dialects is called Tutui. So a completely different name. Those two languages are different, but they share about 40% of the same vocabulary. But in Miriam, it's called Huer na Skaisreda. And Skaisreda basically means twinkling or scintillation. So it means the twinkling stars. And Uncle Allo performed this song for me, and I'm going to play that for you here. Come on. There we go. I've still got to fix that here on the title. It was composed by a man named George Passy. So this song was written by a man named George Passy. He is the uncle of Uncle Seagar and you know, one of the prominent families here on the island. Uncle George Passy, as Uncle Allo described him also, was a very learned man. He earned postgraduate degrees at the University of Queensland, and part of that involved studying traditional knowledge in the Torres Strait. He was also a composer, and he wrote this song, I believe Uncle Allo said, sometime in the 1960s. The old traditional songs are called, sacred ones are called kabkar, but some of the more modern contemporary songs, even though they're still sung in the Meriam language, have a bit more of an upbeat, almost like a, well, he described it as very happy songs, but almost like a church kind of song, something you'd hear in a church. And of course, this is one of the islands where the missionaries from the London Missionary Society first came. It's the color of white is represented in the flag. A lot of different views on that. Of course, the missionaries did bring, you know, they were one of the key elements of colonization, but a lot of the Marian people do practice Christianity in their own way. But this song, Uncle Al's been singing the Marian language. I'm going to see if I can pull forward to show you the lyrics together. I'm going to translate what it means. Actually, I'm going to play this part for you here, because he talks about George passing.
He's one of our greatest composers. He got his doctorate from the University of Queensland. He's a very learned man. Not only that, he composes good songs. Most of the songs are happy songs, and I enjoy most of his songs, and I sing them. The ones that I know, I got it directly from him. He sing those songs to me, and I'm singing them now, and I know all his songs. Not all of them, maybe most of them.
So in the Marian language, the song, the translation is, "Why is it so calm tonight? Why are the stars twinkling so brightly? Or why are they shining like embers in a fire?" I believe it's because of the changing winds, bringing the rain clouds, the rain clouds from the southeast to the northwest. And that's where, if you was looking at the lyrics, you would see the initials NW that were actually refers to northwest. Why are the stars twinkling so brightly? So it's the song, which everybody in the community knows, kids, elders, everybody knows the song, talks about how at the end of the year, in about November, December, you get a period where the trade winds almost stop. It's very, very still. Doldrum is one of the words that is used for that, nautical terms. And even though it's dead calm on the ground, it's very hot, very still, very clear in the sky, you see the stars twinkling. That's because the trade winds are very high altitude. And as they shift from the cooler southeasterlies to the hotter northwesterlies, that's that transition between the Sagir, the Nege, and the cooking season. So this is one of the things the elders look for. Now, before, when I mentioned that the elders were telling me about stars looking very blue, and I was I was trying to figure out where that came from, what that meant, it did dawn on me later on. The reason is because when that starlight comes in, they say if the stars are twinkling and they're appearing very blue, you know it's going to rain. And what we know from basic chemistry is that water absorbs red and green wavelengths of light, but it's very poor at absorbing blue wavelengths of light. So on this little graph here, you can see the wavelengths of light going from purple, blue, green, yellow, orange, and red to infrared. This is the absorption coefficient, so how much of the wavelength is absorbed by water. You can see up in the redder and greener, quite a lot of that is absorbed. But down here in the blue and purple end, very little is. So if it's very humid, that humidity in the atmosphere is actually absorbing those red and green wavelengths of light, but allowing the blue wavelengths to come through. And I've been outside and I've seen it before. I'm sure many of us have. You've been out on the beach, maybe the moon's high up in the sky, and it's got a very bluish tinge, but you notice it's very hazy. And that haziness comes from the humidity, and the bluish tinge also comes from the humidity. It is one of many signs in the sky that you can observe to predict when it's going to rain. Another thing that they utilize in the Torres Strait and mainland Aboriginal cultures all around the world is that of moon halos. So most of you probably at some point in your lives would have seen this big ring around the moon. So this halo goes by many different names, but the conceptual ideas of what it means are universal. In the Torres Strait, they say it's the moon man building a hut to keep himself dry, almost identical to some of the traditions in Uwalyi and Gamilaroi. Uwalyi and Gamilaroi, the elders say that have a look at the moon halo and count the number of stars inside. That'll tell you how many days it's going to be before it rains. So if you look at the halo and it's very crisp, very clear, you can count stars and stuff inside, it probably isn't going to rain, at least not for a few days, if at all. But if you look up, like you see in this image here, it's really hazy. You can't hardly count any stars inside that halo. That means rain is imminent. And the science behind that the Marian people and Aboriginal people and cultures around the world figured out way before Western science did, is that these halos are actually formed by ice crystals high in the atmosphere. And these ice crystals refract the light in a certain, there's a special type of crystal. They refract light in such a way that it shows these halos, which are 22 degrees across. Now, these ice crystals form in low fronts. Low fronts bring rain. So if you see those crystals and there's a low front, but there's very little moisture in the atmosphere, it's not going to condense and fall as rain. But if there's a lot of moisture in the atmosphere and it makes the stars look really hazy, that's what you need. You need that low front, bringing it in so that water will condense and fall as rain. And I've seen this years ago when I came back from the Torres Strait when I was living in Sydney. I went out for my evening constitutional, went for a walk. I saw the moon had a huge halo around it. It was really fuzzy. And later on in the middle of the night, it was bucketing down rain. So, you know, knowing how to observe the properties of the moon in that regard is a fantastic indicator to predict weather. It's not the only one. Cultures around the world look at these moon cusps, or this, I always call it the Cheshire grin because it reminded me of the Cheshire cat in Alice in Wonderland. And this is the crescent phase of the moon, whether it's waxing or waning. When it's setting in the evening, really low in the horizon, it's very close to the sun. It's sort of, it's waxing, getting just far enough away from the sun. The sun will set and you'll see this moon with the cusps kind of pointing upward. And you're going to see that it's just after sunset. And sometimes you can see it while the sun's still up, of course. But where those cusps point isn't always the same throughout the year. Sometimes they're pointed straight up like you see, and sometimes they're tilted off the side. And this tends to happen at two different parts of the year. And in many places around the world where you have a distinct wet season or a distinct dry season, or you get heavier rainfall in one season or the other, they don't always correlate to the exact same thing with each other, but they do correlate to the position of those moon cusps. Sometimes if the cusps are pointing straight up and down, that'll happen during the wet season. Then people will say, oh, well, the moon's filling up with water, that's why it's wet. When it tilts off on the side, it's poured out and now it's dry. In other parts of the world, or in Australia, it's exactly opposite. They'll get a lot of rainfall. They'll get no rainfall when the cusps are pointing up. And they'll say, well, now it's filling up with water. None of it's reached the ground yet. And then when it tilts on its side, it says, now it's pouring water out. That's what's bringing the rains. So it just depends on the context of how you want to see it based on that in situ environment. So Uncle Cigar Passy, here's a photo of him again. All of his paintings, I said, contain multiple layers of complex knowledge. And in here, he shows two different paintings, the moon cusp pointing in two different directions. And when you look at these, you notice something very significant. Look at the types of clouds in the sky. And look at the condition of the water on the ground and the reflection of the moonlight. They're not the same. You get different types of clouds, you get different oceanic conditions. And Uncle Cigar was telling me that this is actually the nicer time of the year, even though the waters are choppier. And this is more the monsoon season, even though the waters are calmer. There's deeper layers of knowledge behind what all that means. But we're starting to run a little bit low on time. I don't want to spend too much more time talking. I want us to get into utilizing stellarium so we can see some of this stuff in action. We've got about another 35 minutes. So just quickly to mention, what about the sun itself? If you were to photograph the sun every night before sunset throughout the year, you're going to see that it's in a different position throughout the year. It makes this weird sort of infinity or figure eight sort of loop. There's a northernmost point where the sun will set and a southernmost point where the sun will set or rise. This shape, this going back and forth on the horizon is called the analemma. The two extremes are the summer solstice and the winter solstice. In the southern hemisphere, when the sun sets at its northerlymost point, that's winter solstice. The southerlymost point is the summer solstice. I still get that confused because growing up in the northern hemisphere in the US was exactly opposite for us. And exactly halfway in the middle of that is the equinoxes. But you're going to notice this loop is bigger here, but smaller there. And you might be wondering, why is that the case? Isn't this where the equinox is, where they cross? The answer is no. The reason these are different shaped loops is because at this time of the year, we're further away from the sun and the Earth actually orbits the sun more slowly. We're a little bit closer to the sun at this time of the year, which means the Earth is moving more quickly. This goes back to Kepler's laws. But again, a lot of these elements of science and solar, lunar, and planetary motion were figured out by indigenous cultures of the world long before Western science did. So that's why it has that peculiar shape where one side looks bigger than the other. But across the country and around the world, people paid attention to these setting positions of the sun and the moon. There's a path of the sun in the sky. I don't really have time to go into that as Uncle Allo talking about the path of the sun. What I do want to do is share you a bit of knowledge that was given to me by David Bozen, the artist I mentioned before who drew the Zugabo Mabaig lino cut. So right here in this image, you can see Badu and Moa Island. And right here is the village of Kuban. And on the village of Kuban, the people look out to this archipelago of islands in the distance. And where the sun sets in the background relative to these islands tells you different things. So sometimes it'll set over an island, sometimes it'll set between an island, but it reaches the northernmost point and the southernmost point. And depending on whether it's gradually moving south or going back and moving north. So as we start at the summer solstice in December, it begins moving north until June, then starts moving back again. It just keeps going back and forth. This pattern of the analemma that we saw before. So on Tuban Island right here, there's a bit of a valley between two peaks here and here. So when the sun sets below that, you know that it's the winter solstice. As you get closer and closer, as that sun starts to set lower and lower, it actually sets directly between these two islands right here. And when it sets between those two islands, it's the start of the summer solstice. The start of the summer solstice happens to coincide pretty much exactly with the start of the monsoon or cookie wet season. But even when it sets between certain islands, when it's moving back north again and sets through here, for example, along the edge of that island, that's when the dugong begin their mating season. So where it is relative to these background islands tells you different things. And here's a simulated image of what it looks like in the background between the islands. So here it is, the summer solstice, the equinox, and the winter solstice. But sometimes it's where it sets like right about here, or at the edge of this island. So again, this is knowledge that was developed very in situ to that local environment, but you find similar uses of it throughout Australia and throughout the world. Now, before we jump into Stellarium and start utilizing that program to see how some of the stuff actually works, I do want to share a couple of bits of information with you. There is currently only one PhD qualified astrophysicist who is Aboriginal. That's Dr. Stacey Mader. Dr. Mader is a Gidjaman from the very tip of Western Australia. He works for the CSIRO as an astronomer at the Parkes Radio Telescope, or the DISH. There's a whole generation of Aboriginal people who were studying astronomy and space science who are becoming the faces of this work, the names of this work. Carly Noon, Crystal Denopoli, and Kirsten Banks, which are already, all three of them, become quite famous now. They've appeared with Brian Cox and Neil deGrasse Tyson. They've been on Q&A and The Drum and all these world famous, or Australian famous and world famous programs. Carly Noon and I are writing a book on Aboriginal, or on Indigenous astronomy right now. And Crystal Denopoli is actually writing a children's book on Indigenous astronomy. The two Peters are both doing some fantastic work, and there's an article coming out in Cosmos next month that I've co-written with Peter Reeve, who's a Barangaroo man who's doing his undergrad at the University of Adelaide, and Pete Swanson completed his undergraduate degree in astrophysics at ANU. He and I have written a little article for the 2021 Australian Sky Guide. So there's lots of new research and new outreach programs coming out where these are the faces that you're going to be seeing and the voices you're going to hear. It's not always going to be some bloody white American guy. And if you want to learn more about this information, anything relating to Australian Indigenous astronomy, you can find it here on our website. A couple of exciting bits of news. I announced last week that 5 asteroids have been named in honor of 4 Aboriginal and Torres Strait Islander people and 1 Torres Strait Islander community. One asteroid is named Miriam for the Miriam community on the Eastern Torres Strait. Another asteroid has been named Sigar-Passi. Asteroid 7733 Sigar-Passi was named in honor of Uncle Sigar for all the work he's been doing in this space. Senior Waterman Elder Bill Edom Delmaharney of the Waterman people outside Catherine. He's been sharing his knowledge of the stars for 30 years, including 2 major books. Professor Martin Nakata, who is a professor in PVC Indigenous at James Cook University. He sort of got a lot of this research kicked off and has been leading initiatives for a number of years, and he's written quite a bit about the cultural interface. And of course, Professor Marcia Langton now has an asteroid named after her for all the work that she's been doing in this space, in particular leading the Australian National Curriculum with regards to astronomy, fire, and water. So it's been really fantastic to see that go through the International Astronomical Unions. Those are all official. There's some media that's come out about that in the last few days, and I've written an article for the conversation that'll hope to come out later this week. So what I'm going to do now is I'm going to end the show here. I want everybody on your devices, your tablet, to pull up Stellarium. Let's open that program because we're going to have some fun with that. I'll continue sharing my screen, but I'm going to pull up Stellarium. I might have to share my screen a bit differently. There we go. Hope everybody can see that. I can't actually tell. Can somebody tell me if you can see that correctly?
Yep, looks good.
Yeah.
Excellent, excellent. Because my version, I've got all the pop-up windows for everybody else off on the side. So this just takes you to whatever default position you're in. You can just, click and drag it around and just see it's sort of a generic horizon, but this is right now, wherever you are. And up here, you can see the sun and the moon. You can click on the sun, or you can click on the moon. You can click on pretty much any object in the sky. Off on the left, you can see a whole bunch of tabs. The first tab we're going to open up is location window. This brings up a map of the Earth. So we're going to, I think right now mine defaults to Sydney. But let's go ahead and just have a look down here in Victoria. Does it really matter in Victoria? Whether you're at Albury or Melbourne, it's going to be about the same anyway. But we'll just go here. Brunswick, in Hipsterland. I live in Fitzroy, the other Hipsterland. This is exactly what's in the sky right now. And over here it says date, time, window. Here's your year, month, day, your hour, minute, second. We're just going to click up until the sun sets and the stars come out. So we can move around, we can see exactly what's going to be up in the sky tonight. And this is kind of assuming fairly low light pollution. You can use your cursor to zoom out or zoom in. But you notice how right now we're in August. Remember when I was telling you about Uncle Gillard telling us in Uwalyi and Gamilaroi traditions that August and September is when the Milky Way and the emu in the sky are perpendicular to the ground? Well, you can see it live in action right here. So here's the head of the emu, here's the Southern Cross, here's the neck, here's the body. It's perpendicular in the sky just after sunset. Because if we go much before that, you can't see it. So about an hour after sunset, bright, perpendicular to the horizon, exactly as we discussed before. Well, let's look at our time. Let's go back 2 months. Let's go back to June. Now we look up in the sky, and we can see that emu going fairly flat and horizontal across the sky. That's the male emu sitting on the nest. And here's the body and the bum of the emu right here. When we go back to April, we can see it just starting to rise above the horizon. Here's the head, the neck, and the body. If we go another hour into the future, really just go into May, we can see the whole emu above the horizon just. But this tells you can look at the behavior patterns of the emu, get online, you can see all the data, but we don't need the data. We have the people who tell us what it means. So these Aboriginal traditions are being used to inform practices in modern science. And a lot of these practices are being increasingly done by Aboriginal scientists, which is fantastic. It's how it needs to be. So we can see the emu here in sort of April and May. We jump forward. This is the emu running. We jump forward. Oh, sorry. We jump forward a couple of months. Then we see the emu sort of across the sky. And then we jump another couple of months ahead. We're now in August. A little bit later because the sun's coming a bit earlier each day, so we can see the emu quite clearly. Now we look, it's perpendicular to the ground. And then we go into November. The days are getting a little bit longer, so we have to go a little bit further into the future. And we see that emu body getting closer and closer to the horizon as each day passes. By the time you get up into November, when you start getting that peak in the rain, you see the emu is very, very low on the horizon. And its bum is just above it. Now, we're actually in Melbourne right now. The emu in the sky in Gamilaroi country be in northern New South Wales. So this would all be even lower in the sky. And what that means in terms of navigation and star maps is something we're going to cover in our lectures tomorrow. So, you know, it's great on your own to have a little bit of fun with this program because there's so much you can do with it. You can actually use some really interesting tools on markings to look at your grid to see where things are in the sky throughout the year. You can see the altitude of stars. The altitude is the angle between the horizon going up in the sky. So let's go back to where we are now. At about 7:30 tonight. So we can see the Southern Cross at 7:30 tonight. It's going to be at an azimuth. That angle on the horizon is going to be in the southwest. The exact azimuth right here is 220 degrees. And the altitude, the angle up in the sky, is going to be about 40 degrees. And that's going to change as the night progresses. The Southern Cross just does this loop in the sky like this, all the way around. But just have a bit of a play with it, have some fun with it. It's really fun. You can actually put in the date of your birth. So I'm actually going to put in, 1978, February 21st. I was born in the state of Missouri, right about here. This is what was up in the sky the night that I was born. So you can see Mars was up in the sky, Orion was up in the sky. I'm asking you to have a play with it because the more personal you make this, the more you tend to be interactive with it. You can see how it works. But a little bit more today. We have another 20 minutes, and then some time tomorrow. We're actually going to dig into this a little bit to see how it works. But I just want to give you a few minutes to have a bit of a play with it. And one of the fun things you can do is you can click on an object like Saturn. Down here at the bottom where all the arrows are pointing inward, that centers it. And then you can scroll to zoom in. You can actually see this is what Saturn would look like if you were to look at it through a telescope. And all these are the moons around it. And you'd be able to see some of them through your telescope. You can see Titan right here. You can even center Titan. You can zoom into that. It's a very powerful software program. And in the academic study of cultural astronomy, we utilize this software all the time. In fact, we utilize it so much, we actually know the people developing it. And every time they put a new version of this out, we ask them to include new things that we can do with this. And one of them, actually, the Stonehenge looking thing is called archaeolines. And this marks out some of the things we look at, like the sun at the solstices and the equinoxes and the major and minor lunar standstills. There's a lot of really neat stuff you can do with this. Anyway, let's get back down to Melbourne, because I want to look at Vega and the Malleefowl. And let's go back in time. Let's go back to 1800. Now, if you don't know where Vega is in the sky, on the left, you go to the search window, you put in Vega. Right now, it tells us below the horizon. So we're going to go forward in time a little bit. Now, you notice it doesn't get very high in the sky. It rises in the east, which is off to the right if we're facing north. And right there, when it crosses that point here, this is the meridian. That's when it's its highest point in the sky. It's a very northerly star, so it doesn't get very high in the sky, as seen from Victoria. But remember, we want to see when the star rises at sunset. So what we're going to do is we're going to simplify things a little bit. We're going to go to landscape. We're going to take out show ground. And we're going to come in here. We're going to look at the horizon. So this is actually the ground. This is everything below the horizon. But for what we're trying to do, just makes it a little bit easier to see things from here. So we want to go to just after sunset. So right about here, when the sun's about 10 degrees below the horizon. So as we can see, when Vega just starts to rise, right about there, this happens in late August, or I'm sorry, early August. So right about this time of the year is when the Nilo and the Mallee hen begin building their nests, building their mounds in their nests. As time goes on, that star starts to move up a bit higher in the sky to where after sunset, when you can see it quite clearly, in about a month, month and a half, you're going to see the Mallee Fel in the stars, Vega, crossing the meridian. It's going to be high in the sky at sunset. This is when they begin, so they begin mating, then they have to begin building their mounds. And then a little bit later, as we go on in time, you're going to see it just about to set. So over here it was a chronicle rise. Now it's meridional crossing. Now we're going to start looking and seeing it at heliacal setting. Heliacal meaning on the same side as the sun. Now it's over in the west with the sun. The sun dips. And just as the stars come out, you'll see Vega for a short time. You'll see Nililund for a short time before it sets below the horizon as well. And that happens in about 2 months. So this whole process of this star being visible in the sky only occurs over approximately 2.5 months because it's a very northerly star. If it were a star in the southern part of the sky, some of them, they never set, ever. You look at stars like, you look at the stars here in the Southern Cross. They're actually called circumpolar. They never set. The South Celestial Pole is about right here in the sky, and they just do loops around that South Celestial Pole. They never go below the horizon. Not from Victoria and Tasmania anyway. The more north you go, they start getting lower and lower on the horizon. This is something we're going to talk about a bit more tomorrow when we discuss navigation and star maps. And what we can gather from all of this is just another recognition of the deep complexity of Aboriginal and Torres Strait Islander people picking certain stars. You have to have a star that represents an animal. Usually the color of the star represents a characteristic of the animal. We talked about Antares many times, referring to, because it's such a red star, being linked to the red-tailed black cockatoo or a red man of that color. You have to find a star that's going to link to the properties, the relative position to other stars, like having two Ys next to him on either side, but also where they're going to rise and set and how long they're going to be in the sky. You can't just pick any random star, because every star that has a different azimuth is going to be up in the sky for a different amount of time at a different time of the year. It's actually incredibly difficult to pick all the right stars to signal all the different things you need to acknowledge, whether it's a changing seasons or the animal or plant behavior. All those things are extremely carefully selected for very specific reasons, because if you didn't have that, it wouldn't make any bloody sense. And then you got to create a narrative around that link them all together. Now, what's interesting about this, and what we can show you on Stellarium, is that the Earth has a special kind of a property. The Earth rotates on its axis, and then it goes around the sun. And it's tilted on its axis by 23.5 degrees. So the Earth is not straight up and down like this, it's tilted off a bit. That tilt is what causes our seasons. Sometimes when the northern hemisphere is angled towards the sun, that's when you get the summer and our winter. The opposite side of the sun, when the southern hemisphere is angled towards the sun, we get our summer, northern hemisphere gets winter. That's what causes that transition. But the Earth itself, over 26,000 years, does a wobble on its axis. And where that projection of the tilt, the north and south celestial poles point, actually wobbles in a process called precession of the equinoxes. And what that means is that everything in the sky is slowly shifting over time. It means where stars, the azimuth of stars, when they rise and set, is going to change very slowly over time. It does this huge full loop. And I'm going to show you over here on the side. So I'm going to pull up these celestial poles. I'm going to pull up the circumpolar circles. So this is the south celestial pole. And, oh, hold on, wrong one, sorry. Precession circle, there we go. Every point along this line here is where the south celestial pole is. That's the point in the sky that just never moves. Everything orbits, everything sort of rotates around that. That actually shifts and changes over time. Every 26,000 years to do a full loop. So because of this, that means the stars shift in their position on the horizon by 1 degree every 72 years. What this means is right now, all the Aboriginal traditions that talk about when certain stars rise and set and their links to plants, animals, and seasons, if you go back 7,000 years, everything is completely out of sync. Those no longer apply. What that means is the knowledge is constantly, slowly, but constantly changing to adapt to new environments. And of course, 7,000 years ago is when the sea level finally reached its highest point. Before that, the sea level was much lower. You go further back in time, the sea level was up to 130 meters lower than it is today. The climate was different. New Guinea and Tasmania were attached to mainland Australia. It was one giant continent called Sahul. That affected how climates and weather patterns shifted, and those affect breeding behavior of the animals. So all this knowledge is not static in time. It has to change, it has to evolve, it is dynamic. New information comes in, has to be adapted, because if you don't adapt to new information, you don't survive. There's no continuity. And Aboriginal people have always been very adept, very good at managing and adapting to new environmental changes. That includes the positions of stars in the sky as they change. So for example, right now that's the south celestial pole. But let's go down here. I put in 1800, let's put a negative sign in front of that. That actually takes us back almost 4,000 years, because it's 1800 back to the year 0 and then backwards another 1800 years. So now we see that it's changed quite a bit in the stars. The positions have changed. Just look at the star here. Try to find a better example of this. Trying to get rid of the atmosphere so it's easier to see. See the star right here, Canopus? That's where the star is in the sky relative to the background stars, relative to the south celestial pole. Now we go back almost 4,000 years and it shifted. We change that even further and it shifts even more. Change it further, shifts even more. Not only are the stars shifting in their positions because of precession of the equinoxes, but the stars themselves are all orbiting the Milky Way galaxy. And as they orbit, they're slowly moving with respect to each other. That means if we go back in time several thousand years, some constellations are going to look very different. They're not going to look recognizable. An example of that's going to be the Southern Cross. So I'm just going to try to pull this back up to the year 1800 again. We can see the Southern Cross right here. Let's zoom into it. I'm just going to get rid of these other markings so it doesn't confuse everybody. We don't care about those right now. All we care about right now is looking at these stars. Now let's go back almost 4,000 years. It looks a bit weird. That star is actually kind of closer down to the bottom. We go back we go back, like almost 8,000 years, 9,000 years. It starts to look really strange because this particular star is moving faster than the rest of them. And it's actually moving in this direction, like this. So if you go back 10,000 years, 15,000 years, the Southern Cross doesn't look like a cross anymore. It looks like something totally different because this star has changed its position so much. And Aboriginal people, of course, when you talk to the elders, they say they've always been here, of course. But even if you go back 10, 20, 30, 40, 50, 60,000 years, 80,000 years, the stars will have gone through a lot of changes in that time. The skies that we see today are extremely different to the skies we would have seen 10,000 years ago, and even more different to skies we would have seen 60,000 years ago. So it just gives you an idea about the constant adaptation and evolution in the sky and the environment, and hence the traditions and the knowledge of the stars and how that has to constantly be adapted to new environments, new climates, climate change. This is something that we're actually working on with some students right now to see how these close connections between the stars, rising and setting position, and the animal behavior is very much in sync. But because of climate change, it's starting to go out of sync. You can measure that change to measure effects of climate change. And of course, this can lead to all kinds of new innovation when you're working with the communities. In the Torres Strait, there's a lot of changes happening. In the northern part of the Torres Strait, the islands are getting flooded because they're very low-lying islands like Boigu and Saibai. I think the highest point on Saibai is only about 1.5 meters high. It's very flat. The rising sea levels are causing tremendous damage. But the elders even on Mare tell me that the behavior patterns of the animals when they breed and mate, like sometimes are coming weeks early or weeks late as the years progress. It's all getting thrown out of whack. It's all going out of synchronicity. So there's a lot of different ways we can better understand the traditional knowledge and ways that the elders can work with modern scientists and become modern scientists. And we can see the interface between these two ways of knowing, something Professor Martin Nagata refers to as the cultural interface. In North America, First Nations colleagues refer to it as two-eyed seeing. And these are Indigenous people who've got the lived experience and the knowledge of growing up in community, but are also becoming scientists. One colleague named Annette Lee, who's a Lakota woman, she's got all of her qualifications in physics, natural physics, and in art, fine art. She's a professor in Minnesota, talks about how it's two-eyed seeing. And their responsibility is seeing with one eye through Western science and one eye through traditional ways of knowing to find solutions to problems that we face in the world today, how these two worlds can come together. So hopefully throughout this lecture today, you will have had an opportunity to get a better understanding of some of the layers of knowledge, some of the complexities behind that, and how they link to predicting weather, seasonal change, and the behaviors of animals. We've talked about the positions of stars, and we've talked about some of the changing properties of stars, including their brightness and their twinkling, and even their color. We've had a little bit of a go on Stellarium, and I highly encourage you on your own time, just have a play around with it. I mean, I could spend an entire semester teaching you how to use this, and I'm still learning new stuff on here all the time. And it's more difficult if you don't have a background in astronomy to know what half the stuff even means. But have some fun with it, have a go with it, and when you read the papers, especially the middle paper that I posted on LMS about wildlife that Trevor Lehman wrote, look at those connections between the stars and the animals and the seasons, and get on the Stellarium and try to test it out for yourself. Just see how it works. Put yourself in that location where those stories are recorded, that time of the year, look up the stuff the elders are telling you about the behavior of the animals, and see how it links together. It's just a great way of being able to visualize it yourself. So I'm going to